Okay. Okay, so this first chapter actually just a revision from the UG. Okay, stereochemistry. Yeah. Okay. Okay, so okay, if we look at the isomer, actually we can divide to two. Okay, first is structural isomer, or we call constitutional isomers. Okay, another one is the stereo isomers. There are two different types. The first one is a differ in their bonding sequence. Okay, if you look at these two examples, okay, for just two example, if you count the number of carbon, hydrogen, and fluorine, they are exactly the same. Okay, between these two compounds, but they differ in bonding sequence. Okay, for example, like the first one is a carbon, carbon, and then fluorine. Okay, but the second one is a fluorine, carbon, carbon. Okay, so this is an obvious difference between these two. So these are under structural isomer. Okay, the second one is a stereoisomers. It differ in the orientation. And this is a keyword. Orientation in the atoms in space. Okay, mean the bonding sequence is exactly the same, but only differ in the orientations. Okay, for example, like these two. Okay, these two compounds. Okay, if you look at these two compounds, the bonding sequence is the same. Okay, it's exactly the same. I mean, this is a carbon attached with the bromine, chlorine, fluorine, and hydrogen. It is same with this compound. It's also bonded to fluorine, chlorine, bonding, and hydrogen. But the orientation is different between these two. Okay, so I mean for this lecture, we're going to learn how to name and how to differentiate uh, between these two compounds using RS system. Okay, so we also have a cis-trans or EZ isomer, means a double bond sp2 carbons. So let's say between these two compounds, they also have different orientation. Okay, but it's the same bonding sequence. Okay, they're also under stereoisomer. Okay. Okay, first is a chiral. What is a chiral object? Okay, there are a few important terms that you must understand. Okay, the first is a chiral. What's a chiral object? I mean, has a mirror image that is a different from the original object. Okay, so the keyword here is a mirror image. It's a different, okay, from the original object, and it cannot be superimposed. It cannot be superimposed between original and mirror image. Okay, the classic example used in many books using hand. Okay, I mean your right hand. Okay, in the front of a mirror, you will get your left hand. Okay, your left hand image. Okay, and then these two. Okay, if you try, you can try now. If you can match your right and left hand. Okay, of course you cannot mesh it, right? Okay, because it cannot be superimposed. So we can conclude hand is a one example of the chiral object. Okay, chiral object. For a chiral, mean the object can be superimposed. Okay, can be superimposed. That's what we call a chiral. Okay, the example, if you're using this chair, okay, in the front of mirror, okay, we get this mirror image, okay, and then we can superimpose. I mean they are exactly 100% same. Okay, you can superimpose. You can superimpose. It's exactly the same. Okay, so this one we can conclude as a chiral. This is a chiral object. Okay. Okay, just quick activity. Okay, can we identify this object chiral or a chiral? Okay. Okay, this shoes. Is it chiral or a chiral? Okay, I give you 2 seconds. Okay, it's a chiral, right? Why? Because the mirror image cannot be superimposed. Okay, so this is a chiral object. Okay, how about this beaker? Okay, this beaker also a chiral. Okay, good. Okay, it's a chiral. Okay, because it cannot be superimposed. Okay, how about this symbol?
Chiral.
Okay, excellent. Okay, this
Chiral.
okay, this is a chiral. Okay, a chiral. Why? Because the mirror image is 100% the same. Mean we can superimpose. Okay, mean the mirror image of this symbol we can superimpose. Okay, so we call it a chiral object. Huh? A chiral object. And why chirality is important? Okay, why important? Okay, I give you 1 point. Okay, if you study this six compound, okay, this six compound, okay, this is isomers. This a pair is isomers using a RS system. Okay, for example, like pronanolol. This for the R pronanolol. This one used to for the beta blocker, for heart disease. Okay, but for the S pronanolol mean is a isomer using for different purpose. This one for the contraceptive. Okay, so you can look at this example. Okay, I mean the structure almost the same, except for 1 point that differ the stereoisomer. Like this one is a SS, this one with the R. Okay, for SS, this one using to for the anti tuberculostatic or anti TB. Yeah, it's a for SS. Okay, but this one for RR is a cause of blindness. Okay, mean one be used as an anti-TB, so another one can cause a problem. Yeah, can cause a problem. Okay, so it's that's why important, especially for the drugs companies. Do we make sure that they synthesize the right isomer? Okay, if not, they are in deep trouble. Okay, so this is another classic example. Uh, this one we call talludinite. Okay, sorry, I actually this disturbed me. Okay, uh, thalidomide. This one is introduced by one big company at the time, Camille Jonan from German, 1957. 1957. But it's in form of racemate. Racemate means it's not pure R or S, but it's a mixtures S and R enantiomers. Okay, so the problem okay, and then this drug actually to treat insomnia and also to reduce nozzles shed to pregnancy. Okay, and then it introduced 1957. Okay, by 1960, 3 years later, the drug was in more than 20 countries. Okay, especially in Europe and Africa. Okay, in 3 years, okay, it sell to more than 20 countries. Okay, but the problem, okay, 1 year later, okay, the newspaper reported have a problem taking the drugs. Okay, and then you look, okay, there are more than 10,000 case of newborn in 40 countries have a problem with the deformations, with the deformation. Okay, so the problem, okay, if in terms of chemistry, okay, in terms of chemistry, okay, when we study about the problem, okay, we found that this is the problem. Okay, at this site, this is a different site. Okay, one for the effective isomer. Okay, the another one is for the multigenic isomer. Okay, that's why important to make sure which one the correct isomer. Okay, before getting to the market. Okay. Okay, so we back to the chemistry part. We back to to the chemistry part. Okay, so you learn already about the chiral object. Okay, when we apply to a molecule, okay, apply to compounds, okay, so we use terms enantiomer. Okay, first we use term enantiomer, means a non-superimposable mirror image, different molecule with different properties. Okay, it's the same with the chiral object, but this one we want to apply for molecule, for compounds. Okay, so we use term enantiomer. Okay, enantiomer mean a mirror image that cannot be superimposed. Okay, so for example, like these two compound, um, how to name this compound? Anyone can give name for this compound? Sorry. These are two butane, right? This is a 2-butane. And this is a 2-butane. One is a R, another one is a S. Okay, mean these two, they are different compound. They are different compound because they cannot be superimposed. Okay. Okay, the next terms, okay, it's a chiral carbons. Okay, what is a chiral carbon? Okay, chiral carbon is a carbon with 4 different group, okay, attached. So that's what we call chiral carbons. Okay, it's a mirror image will be a different compound, or we call enantiomer. Okay, for example, like these two. Okay, this carbon has 4 different group. Okay, so this carbon we call chiral carbon, and this is a chiral carbon, and this is a mirror image. Okay, and it cannot be superimposed because it have the 4 different group. Okay, but for a chiral compound, okay, it can be superimposed. It can be superimposed. Why? Okay, if you look at this model, okay, this one, two, this group number 3 is the same. This is the same group attached. Okay, so this is the mirror image. This is the mirror image. Okay, so if you hold group 1 and then you rotate, okay, you rotate this side, okay, you rotate this side 180 degree, so you get the same as the first structure. Okay, so if compare, it's the same, exactly the same with the first structure. So this one we call a chiral compound, a chiral compound, or actually it's the same compound. It's the same compound. Okay, so everything we mesh. Okay, everything we mesh because it's the same compound. Okay, so when the image can be superimposed, okay, so the conclusion you can say that it's a chiral. Okay, the next term is a plane of symmetry. Okay, what is a plane of symmetry? Okay, this is a plane of symmetry. Mean if a molecule that is a plane of symmetry, so it's a chiral. Okay, so mean the plane, okay, that we can add. Okay, so in this side, the left and the right side is exactly same. Okay, exactly same. So we can say that it's a chiral. Okay, it's a chiral. Okay, when we apply for cis and trans, okay, cis and trans compound for cyclic. Okay, for cis, okay, the conclusion is a chiral. Okay, why we can say that it's a chiral? Okay, because it has plane of symmetry. So if I put the plane here, okay, sorry. Okay, if I put the plane here, okay, so mean the left side and the right side is exactly the same. Okay, exactly the same. Okay, this is the same compound and it's a chiral. But for trans, it's a chiral. Okay, because if you put plane here, the left and right side there is not 100% same. Okay, that's why for this one it's a different compound. Okay, this is a different compound, so it's a chiral. Okay, it's a chiral. Okay, and then for trans, doesn't have a plane of symmetry, so it is a non-superimposable of the and then the molecule is a 2 enantiomer. So I mean there are 2 different compound. These are 2 different compound, but for this one they are same compound. Okay, they are same compound. Okay, So just a quick activity. Just quick activity. Okay, identify each asymmetric carbon atom. Okay, asymmetric carbon atom mean chiral carbon. Okay, in some books they use terms asymmetric carbon. Okay, but it's the same with the chiral carbon. Okay, in the following structure. Okay, so you can, I give you, okay, 30 seconds to identify how many chiral carbon for compound A. Chiral carbon mean carbon that have 4 different groups attached to 4 different groups. Okay, so how many carbon actually chiral carbons? Okay, anyone try?
1 carbon.
Sorry? 3 carbon. Okay, 3 carbon. So okay, so we can check together. Okay, this is the first one, right? This is the first one. Okay, first this is 1, 2, 3. Okay, so there are 3 chiral carbons. Okay, good. Okay, how about the second one? Second compound. 2,
4.
4, right? Okay, good. Okay, the answer is a 4. Okay, 1, 2, 3, 4. Okay, so there are 4 carbon that has 4 different groups attached to the carbon. So that's a definition for the chiral carbon. Okay, good. Okay, so you understand the concept. Okay, good. Okay. Okay, this is the next questions. Okay, to make sure that you understand or not. Okay, from the previous slide. Okay, draw a 3D structure. Okay, 3D structure for each compound. And star all asymmetric carbon, mean chiral carbons. Draw the mirror image for each structure and state whether you have drawn pair of enantiomer or just the same molecule twice. Okay, so we look at the first structure. Okay, I give you 2 minutes to try. Okay, and then we discuss. We discuss together. Okay, first draw. How to draw? Okay, if you refer, sorry, okay, this okay, you take the compound first. Okay, this is a 2 pentanol. 2 pentanol. Okay, 2 pentanol. Okay, and then you draw 3D like this. This is a 3D. Okay, you can refer to yeah, to this one. Okay, this is a 3D. Okay, this is a 3D structure. We draw 3D structure. Okay, for 3D structure, okay, it has a 3 group on the plane. Okay, 1, 2, 3. This is a 3 group on the plane. 1 group toward us. Okay, the another one is away from us. Okay, normally we add the lowest purity, which is hydrogen at the back. Okay. So when you want to draw, actually there are many there are many ways how you want to draw the 3D structure, but this is the standard one. Okay, mean 3 on the plane, 1 pointed toward us, another one away from us. Okay, away from us. Okay. So from the equation to pentanol, you just need to replace the group. Okay, replace the group with the 2 pentanol. Okay. Anyone get it? Okay, so for 3D model, if you're familiar with this one, previously we learned using this atom, this model atom. Okay, so we can visualize the compounds, okay, using this model. Or now actually you can use ChemDraw. You can use a ChemDraw to assist you. So I will share you. Okay, I will stop this one. Stop sharing. Stop sharing. Oh, I cannot share. Okay, that's okay. Share. How I can change? I want to share the ChemDraw. Share content. ChemDraw. Okay, this. Okay. You can see this one. ChemDraw. Guys.
Yes, doctor.
Yes, doctor.
Okay. So this is actually structure for 2-pentanol. 2-pentanol. Okay. So if you want follow for the standard for the 3D structure, so we draw like this. We draw like this. I mean there are 1, 2, 3 group on the plane. One pointed toward us. Okay, so this another one is a H. This is away from us. It's a H. Okay. So but actually if I play, okay, if I use this one, okay, if I play this one, sorry, cannot move, it cannot move. Oh, I'm not sure why. Okay. Okay. Actually, we can draw other forms. Let's say like this one. Okay, if you okay, or this one. Okay, but make sure that you understand. Okay, but just to be safe, if you can just follow for the standard one. Standard ones, I refer to the slide. I refer to the slide. So sharing content. Okay. Oh. Share. Okay. Okay. So this is 1, 2, 3 on plane. One is toward us. This another one is away from us. Okay, so it's a OH group. Okay, so this we can put this group. Okay, it's a H2, CH2,
CH2.
and CH3, right?
CH2.
Okay.
Yes.
Okay, difficult to draw using mouse. Okay, this is CH3. Okay, this is CH3. Okay, so this is CH3. Okay. I mean this is a H, with a H. Okay, this is this is the 3D structure. Okay, 3D structure.
Yes.
You just using this template, just change the group. Change the group. Okay, so we already draw the structure. Okay, and then we have a mirror. Okay, and then we have the mirror image. Okay, we have the mirror image. Okay, so it should be like this. Okay, okay, this one toward us, this one away from us. Okay, and then just copy here, right? You get it right? OH is a H. Okay, just copy back. Okay. Okay, draw. Okay, done. And star all the carrier carbon. Okay, we just star the carrier carbon. So in this case, only one carrier carbon. So you just put the star symbol. Okay, star symbol, and then draw the mirror image. Done. State whether you have drawn a pair of enantiomer or just the same molecule twice. Okay. In this case, because there is no plane of symmetry, okay, so this is a enantiomer. It's a pair of enantiomer. So one will be R, another one will be S. Okay, the one that we will learn later. Okay. Any questions so far? Okay. Or I teach
Okay, doctor.
too fast. Okay. Okay, good. Okay. You can practice with a B and C and D. You can practice later. Okay. If you have problem, and then we can discuss in next class. Okay.
Inshallah.
Uh, okay. I will take another 20 minutes. Yeah, 20 minutes. I will go for the R and S nomenclature. Okay. So we have enantioma. So we need to name the enantioma. So we name using R and S system. Okay. And then you have initially this a different molecule. Enantioma is a different molecule, have a different names, and usually only have only one enantioma will be biological active. Okay. For example, like alanine, it's a natural, it's a this alanine. Okay, and this is the mirror image. It's a unnatural alanine. Okay, I mean this one we can synthesize in lab for this unnatural alanine. Okay, and then configuration we use system RNS. Okay, RNS. Okay, so for RNS, okay, the rule that we use is a CIP rule. It's a Can-Ingles-Pirox rule. Okay, so in this rule, first we need to assign a purity number to each group attached to the chiral carbon. Okay, and then the purity is assigned according to atomic number. Okay, this is a keyword. This is atomic number. The highest atomic number assigned is the highest purity, I mean purity number 1. Okay, because the chiral carbon has 4 different groups. Okay, so the purity will be purity number 1, 2, 3, and 4. 4 normally for hydrogen. Okay, in case of tiles, it's the same. And then look at the net atom along the chains. Okay, double and triple bond are like bond to the duplicate atoms. Okay, so to assign ROS, okay, working in 3D, okay, it's a 3D, rotate the molecule so that the lowest purity group is in the back. Okay, so we rotate so that the group number 4 at the back, at the back. Okay, draw an arrow from the highest to lowest purity group. Okay, I mean from purity number 1 to purity number 3. Okay, 1, 2, 3. Okay, if a clockwise, we give a sign R. If a counterclockwise, is a S. Okay. Okay. For example, like this one. Okay, first we assign the purity based on the atomic number. Okay, atomic number. Okay. So this is the chiral carbon. Okay, this is a chiral carbon. So there are 4 atoms attached to the chiral carbon. Okay, so we are talking about the atom directly bonded to chiral carbon. We are not considered as a group. This is not a group, but as a atom. Okay, bonded, the directly bonded atom. Okay, so in this case, this is a carbon, fluorine, hydrogen, and nitrogen. Okay, and nitrogen. Okay, so based on the atomic number, okay, fluorine cat number 1, nitrogen number 2, carbon number 3, and hydrogen number 4. Okay, hydrogen number 4. Okay, and then the lowest purity group should be moved at the back, the back. So in this case, already at the back. Okay, so no problem. Okay, if not, mean we need to rotate so that purity number 4 at the back. Purity number 4 at the back. If you can see this model, 1, 2, 3, 4. Okay. Okay. So if you can see this model, okay. Let's say this hydrogen. This hydrogen. So if the hydrogen already at the back. Okay. So in this case already at the back. It is a front. Okay, at the back and no problem. Okay, no problem. Okay, but if the hydrogen not at the back, so what we could do, we hold one group and then we rotate so that the H at the back. Okay, that's it. Okay, and then we assign group 1, 2, 3. Okay, if a clockwise it's R, if a counterclockwise it's a S. S. Okay, so in this case, okay, it's a 1, 2, and 3. And this is a counter clockwise, right? This is a counter clockwise, so it should be S. This is a 1, 2, 3. Okay, so it will be counter clockwise. Okay.
Forwards.
Okay, good. Okay, this is an example. If we want to rotate the priority group number 4, hydrogen. Okay, if in this case, okay, because the hydrogen toward us, okay, mean we need to
Yeah.
have one group. In this case, we hold this group, right? We hold this group, okay, because this is the same, this move, and then we rotate. Okay, we rotate. It can be like this. Okay, we can rotate like this, so that this group at the back. Okay, OH at the front. Okay, you see, it's a OH
Yeah.
at the front, H at the back, and this group, ethyl group, okay, at the top. Okay, at
Yeah.
the top. Okay, so this is an example. If the group number 4 not at the back, so we need to rotate. Okay, good. So in this case, it's a clockwise. It's a R. The 1, 2, 3. Okay, so it's a R. Okay, treatment of multiple bonds. Okay, treatment of multiple bond mean if the atom attached to double or triple bond, so it will become like this. Because for CIP rule, you need 3 atom attached to the chiral carbon. Okay, so if we have like a double bond, so mean there are only 2 atom. So we need add another one. The one is the same with the neighbor. Okay, with the neighbor atom. If C double bond C, okay, so mean this one bonded to C and this one also bonded to C. If a C double bond N, okay, so it will be CN. Okay, why N? Because N is next to carbon. Okay, this is C double bond N, so it will be C N N C. Okay, this is the same example here. If a C double bond O, okay, if a C double bond O will become like C attached to O, O attached to C. Okay, so that it has a three atom attached to the chiral carbons. Okay, this is another example. Okay, this is another example how to assign R of S. Okay, first we look atom that bonded directly to the chiral carbon. Okay, so this is a chiral carbon, right? Only one chiral carbon. Okay, so we have
Yes.
one atom. Okay, 1, 2, 3,
3 and 4.
okay, so there are 4 different, these are 4 different groups, of course. Okay, that's why it's a chiral carbon. Okay, there are 4 different atoms attached to the chiral carbon. Okay, so based on the atomic number, okay, this one, this is obvious, this is number 4. Okay, this one, priority number 4 at the back. Okay, but we have problem here because these 3 had the same atomic number, right? It's the same atomic number, so it's draw. I mean, we cannot assign 1, 2, 3 based on this is the first rule. Okay, so how to solve it? Okay, when draw, we look at the atom attached to these 3 carbon. Okay, attached to these 3 carbon. If I draw in the full structure, okay, I mean this carbon attached to 3 hydrogen, right? It's a 1, 2, 3. Okay, I mean this carbon attached to 3 hydrogen. Okay, the button carbon, the button carbon, this one attached to 2 hydrogen and 1
Carbon.
carbon. Good. Okay, 1 carbon. Okay, I mean this carbon, I'm talking about this carbon, 1 carbon, 2 hydrogen. Okay, how about this carbon? It attached. Okay, when you see this a double bond, okay, it treated,
2 carbon,
yeah, 2 carbon. Good. Okay, this is 1.
1
Okay,
hydrogen.
this is number 2, and this is number 3. Okay, I mean these are 3 atoms. Okay, so how to solve it? We look at the highest atomic atom. Okay, we not combine or we not total up, but we need to look at the highest atomic atom between these 3. So here we have carbon. Okay, The highest one also carbon, and this one, the highest one is a hydrogen. Okay, so mean this group,
Hydrogen.
this number 3. This go to purity number 3. Okay, because the highest
Yes.
atom that attached to the carbon is hydrogen. Okay, these two stay draw. If draw, we look at the second highest atom, which is a carbon, but this one is a hydrogen. Okay, this is a carbon. Number 2 is a carbon. Number 2 is a hydrogen. So this group will be number 1, and this group will be number 2.
Number 1.
Okay, so we have complete 1, 2, 3, 4. Okay, H already at the back, so no need to rotate. Okay, we just assign 1, 2, 3. Okay, 1, 2, 3. So it will be clockwise or anti-clockwise? Should be counterclockwise, right?
Clockwise.
Yeah, counterclockwise. So it's a S. Okay, it will be S. Okay, so we can, so it's a S. Okay, easy, right? Okay, good. Okay, okay, so this one, to draw the enantiomer, 1,3 dibromobutane and label as a S or R. Okay, it's the same as the previous one. Okay, I mean you need to draw 3D. Okay, you need to draw 3D using this format. Okay, and then you have the mirror image, right? The mirror image, the enantiomer. Okay, and then you need to assign which one is a R or S based on the CIP rule. Okay, but actually this one is already solved. Okay, so we look at the solution. Okay, main this a 1, and then you have the mirror image. Okay, so this is the mirror image. Okay, so how to assign? We to make it easy, we put H at the back. Okay, so this is a bromine. Okay, and then this is a carbon. This is a number 2 for this group, and methyl as a group number 3. Okay, so the parity 1, 2, 3 is a clockwise, so it's a R. Okay, and then the enantiomer must be S. Okay, one way to check either you give the correct or incorrect answer. One R, another one must be S. If you get, let's say, both S or both R, mean there is something wrong. Okay, there's something wrong. So in this case, there's a 1, 2, and 3. So it's a counterclockwise. Obviously, it's a S. Okay, it's a S. Okay. Okay, so I think I want stop after we done for this activity, these questions. Okay, this question assign relative priorities to the following compound based on the CIP rule. Okay, I mean we need to assign which group has a number 1, 2, 3, and 4. Okay, so I will show you the first one. Okay, then I want you to try for B and C. Okay, so the first we look at the atom bonded directly to the chiral carbon. Okay, so I mean this is a chiral carbon. Okay, I mean dash mean this is a chiral carbon at these positions. Okay, obviously this is a carbon. This is a hydrogen, lowest atomic number, get number 4. Okay, these 3 have a carbon. Okay, have carbon means they draw. We look at the atoms bonded to these 3 carbons. Okay, for the first one is bonded to oxygens and 2 hydrogens. Okay, the second one bonded to 3 hydrogens, and the third one is bonded to 1 carbon and 2 hydrogens. Okay, so we take the highest atomic number, which is oxygens. This one hydrogen. This one is a carbon. Okay, obviously this oxygen has highest atomic number. We get number 1. Okay, and then this group carbon get number 2, and methyl group get number 3. Okay, easy, right? Okay, if easy, you can try B and C. Okay, I give you 5 minutes. Yeah. Okay. 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 Anyone want try question B?
Yes.
Give me priority number one. Which group? Priority number one.
Number one, I think CH.
Number one.
Oh,
CH.
CH double O. Yes, number one.
CH. Okay. CH double O. Okay. So number one. Number two.
Number OH.
OH. This is number two. Number three.
CH2. CH,
Two OH.
CH2 OH.
OH. Okay. And CH3. This is number four. Okay. Anyone have a different answer? All the same?
2143.
Sorry?
It's two vector.
So instead of
Aldehyde is a two.
Aldehyde is a two. Okay, this is aldehyde number two.
Yes.
Okay, number one.
one,
OH1.
OH.
One.
Okay, hydroxy.
One.
Yeah? OH hydroxy. This is the same, right?
That is
Okay. Okay, good. Okay, good. Okay, so you already try, so it's good. Okay. The first one. Okay, we need to look at the atom bonded directly to the carbon. Okay, so we are talking about this carbon. Okay, this oxygen, carbon, carbon. Okay, we are not looking at the group. Okay, we're looking at the atom bonded directly to the to the carbon. So obviously, this oxygen has higher atomic number. Okay, so oxygen number one. Okay, and then these three draw.
Okay.
Okay, if a draw, we look at the atom, okay, bonded to the carbon. Okay, bonded to the carbon. So the first one, this carbon is bonded to oxygen and hydrogen. Okay, but based on the CFP rule, it must be three atoms. Okay, because it's a double bond, so it's like bonded to another oxygen.
carbon.
This is oxygen.
Oxygen. Yeah.
Yeah, because the net is a oxygen. Okay, so this oxygen is like bonded to another one carbon. Okay,
Yes.
so another one carbon. Okay, so in this case, this carbon bonded to two oxygen and one hydrogen. Okay, this carbon bonded to three hydrogen. Okay, this carbon bonded to one oxygen and two hydrogen. Okay, so we pick the highest atomic number. This oxygen, this is hydrogen, and this is oxygen, right? Okay, so this one definitely number four. Okay, this one number four. Okay, this one draw both oxygen, and then we take the second highest atomic number. Okay, which is hydrogen. This one oxygen. Okay, so this group number. What I'm doing? This is number one. So this is number two, and this is number three.
Number
Right?
two.
Okay, so it will be OH number one, this aldehyde number two, and then this alcohol number three, and methyl group number four. Okay, good. Okay, good. Okay, how about C? Anyone want to try? This is a purity number.
four,
That is a number
It's
four.
two.
Yes.
It's okay. This is number two,
Four, four, two,
one,
one,
and three.
three.
Okay, anyone have a different answer?
Yes, bro.
Okay, this is a number.
The first one is two. Two.
Number two.
Two.
Okay. The second one.
And we have three.
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 Okay, three. Okay, chlorine.
One. Four.
Okay, and then four.
One more.
Okay, good. Okay, have another answer? No, only these two, right? Okay, so we check. We check together. Okay, so number one is a clear. It's a clear cut. Because chlorine has a higher atomic number than carbon. Okay, so this is number one. Good. Okay, and then this three group has a carbon. Draw. Okay, this carbon
Yes.
bonded to one carbon, two hydrogen. Okay, means bonded to carbon, hydrogen, and hydrogen. Okay, this carbon bonded to one carbon, also two hydrogen. Okay, interesting. Okay, and then this one bonded to two carbon, right? And one hydrogen, right? Because this is a carbon bonded to two carbon, right? This is a two group. Okay, if you draw, okay, if I draw this one, actually it's like this, This is CH3. Okay, this is CH3. This is CH3, and this is H. Okay, mean bonded. This carbon bonded to two carbon and one hydrogen. Okay, one hydrogen. Okay, so we can check the highest one. So carbon, 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 draw, and then carbon, hydrogen, hydrogen. Okay, so this one we get number 2. Okay, this one we get number 2. Okay, and then this 2 is a draw. Hydrogen, 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 hydrogen. Okay, if draw, we need to look at the next atom. Okay, we need to look at the next atom. Okay, I'm talking about this atom, this carbon. Okay, we need to look at this carbon and this carbon. Okay, these two carbon also bonded to three another atom. So in this case, it bonded to bromine. Okay, bromine and two hydrogen. Okay, this carbon bonded to one bromine and two hydrogen. Okay, this carbon bonded to one carbon and two hydrogen. Okay, using the same principle. Okay, we compare the highest one, carbon and bromine. Okay, so bromine has higher atomic number than carbon, so we get number 3. Okay, so we get number 3, and then this one number 4. Okay, so the second answer is correct. Okay, 1, 2, 3, 4. Okay, agree? Or wanna have another thought? Agree, right? Okay, good. Okay, so this one I will stop at this slide, and then I will continue, inshallah, next week. Inshallah next week. And then the timetable, I need your help to put in the WhatsApp group your timetable, so then I can suggest a new timetable that suit for everyone. Okay.
Thank you, Doctor.
Okay.
Okay. So before I dismiss this class, anyone want to say something? Want ask anything?
Doctor,
Yeah.
my
Doctor?
attendance recorded or not? I'm not sure.
Yeah, this one recorded. So I will upload in e-learning. If the file is not too big, if the file is okay, and then I will try to upload. Okay. And then if you
Doctor?
yeah sure. Who's that?
I cannot, I couldn't scan
You couldn't scan. Okay.
the attendance.
Me too.
Okay. No
Me
no
too,
no
Doctor.
No problem.
no problem, because I already confirmed that you are here, so you already attend. Okay. So I will stop
Okay.
this one before almost 1 hour.